This time we are going to verify whether the given transformation here, R2 to R2, given with this transformation of xy is equal to x plus y and y, whether this is a linear transformation or not. To do that, we are going to satisfy or show whether these two conditions are satisfied. The first condition is when we are going to take the transformation of their sum. Okay, the transformation, let's use here u plus v. The transformation of the sum of vectors u and v, whatever would be its components, is equal to the sum of their transformation. Okay, this is what it meant by this condition. The transformation of the sum is equal to the sum of their transformation. The second condition is if we have here a transformation of a multiple, scalar multiple of a vector u, okay, this is equal to the product of the same scalar and the transformation of the same vector u. If those two conditions will be met rather, definitely we can have a linear transformation. But if won't, or one or even two of them will not be satisfied, then this means that our transformation here is not linear. But to do that, let's try to come up with components for our two vectors. Let's have here vectors u and vector v. Since our components are x and y, let's write like this. Our vector u would be the sub 1s, x sub 1 and y sub 1. And our vector v would be the sub 2s, x sub 2 and y sub 2. So we are going to show this here. So let's start with the first. We have here the transformation of the sum of vectors u and v is equal to, or I mean must be equal to, the sum of their transformation. So let's substitute first here the components of the two vectors. You have x sub 1, y sub 1 for your vector u, plus y sub 1, I mean x sub 2 rather, and y sub 2 for our vector v. Their sum before taking out the transformation, because we have here two components only. Let's try to add them. You have your x sub 1 plus x sub 2, y sub 1 plus y sub 2. Since we now have two components, let's try to come up with their transformation. The transformation, x meaning the first, so this is the first here, so x sub 1 plus x sub 2 plus y would be our second, y sub 1 plus y sub 2. Then, alone, here y sub 1 plus y sub 2. To show that we are going to have the transformation of u plus the transformation of v, take note that for u, we are using here the sub 1s, and for v, we are using with sub 2s. So in this case, let's try to manipulate the expressions here where we're going to combine all the sub 1s into one group and the sub 2s in another group. In short, we have here x sub 1 plus y sub 1, okay? And then you have here plus x sub 2 plus y sub 2. Then, since we only have two components here, so it will just be like that. Then, once you take out this together with this first, these are actually the sub 1s, right? So we have here x sub 1 plus y sub 1, and then y sub 1 plus, because these are both addition, plus you will have your x sub 2 plus y sub 2, and then y sub 2. This is actually equivalent to our transformation here, x plus y, and then y. X plus y, and then y. Same thing as the second, x plus y, and then y. And since we are using here, or in our first here, you have sub 1s, and the second we have sub 2s. So this means that the first one here is a transformation for the vector with sub 1 components. You have your u. Okay, that's your u. Plus, these are sub 2s, so that's the transformation of your v. Now, we have shown that from here, we reach to this. So we have satisfied the first condition, telling us again that the transformation of the sum is equal to the sum of their transformation. Let's proceed to the second condition. Okay, If ever this first condition was incorrect, then definitely we don't need to move to the second. But since we have satisfied the first condition, let us try to also check whether the second condition is also satisfied. So let's try here C as any scalar. In short, your transformation of C times your vector U can be written as the transformation of C times the component of your vector U, the sub 1s, x sub 1, x sub 2. And let's multiply it first. C x sub 1, C y sub 1. Then from here, let's come up with our transformation now. So this is actually using this one here. So the first plus second, C x sub 1 plus C y sub 1. And then you have your second, C y sub 1. Our goal is to come up with this expression where the C is outside the transformation. So let's try to factor out C in both components. So C x sub 1 plus y sub 1. And the second here, you can also write it like this. But of course, this is already multiplication, so you don't need to. But just for the purpose of illustration, let me have it like this. Now that we have C here and C dito, just like what happened here, you can simply take it out. So C times, you have your x sub 1 plus y sub 1, and then you have y sub 1 here. This, just like what happened earlier here, this is actually the transformation of your U. So you have your C times the transformation of vector U. And we have satisfied the second condition as well. With these two conditions already satisfied, we can now say that the given here is a linear transformation. Okay? Again, the process here involves these two conditions and the correct algebraic process that you can think of. Take note that the goal is, of course, come up with these forms here. So you just need to manipulate your entries or components of your transformation. Thank you very much for watching.